If you look at the map of the African continent, located in the northern region is one of the largest deserts in the world. Unlike the rest of the continent, this place isn't as accommodating as you hope. Turning a desert into a green forest sounds like the stuff of fantasy movies. This seems like a fictional thought, considering we're talking about over 3.3 million square miles of sand. It sure makes you wonder if it is possible or if this is just nonsense. Scientists think otherwise, as they have come up with a plan to do just that. So join us as we look at how scientists plan to achieve this feat right here in this video. Many people have heard about the Great Sahara Desert, considering it's the largest hot desert in the world and the third largest desert following the Arctic and Antarctica. Like you would expect from a hot desert, the Sahara is covered in so much sand that it spans a land area equivalent to China or the United States. However, it wasn't always covered in sand. What you see today is a huge desert land used to be a vast sea named Tethys about 7 million years ago. According to some of the latest computer simulations of Earth's early climate, it was discovered that the movement of tectonic plates, which created the Mediterranean Sea and the Alps, also began the drying up of the Sahara Desert around 7 million years ago. Climate conditions in the Sahara region haven't been stable for the last several million years. This is mostly due to the minor changes in Earth's tilt toward the sun over time, which increases the quantity of the solar energy that the northern hemisphere receives in summer. This alters the atmospheric currents while driving monsoon rains. North Africa also sees more precipitation when less of the planet's water is locked up in ice. This leads to an increase in moisture, limiting how far the Sahara Desert can spread, even sparking times when abundant lakes, plants, and animals replace the desert. This was known as the Green Sahara. This supports the idea that Northern Africa used to have a milder climate, and it's reinforced by evidence such as the ancient dune deposits found in Chad. But scientists work with facts, and without explaining how it emerged, most scientists claim that the Sahara took shape just 2 to 3 million years ago, with only a few agreeing that the desert could be about 7 million years. Terrestrial and marine evidence suggests that North Africa underwent a period of drying when the Northern Hemisphere started its most recent cycle of glaciation. Scientists and researchers have attributed the advent of the Sahara Desert 7 million years ago to this reason. They also claim that this phenomenon would have affected the plants and animals in the region, even extending to the possible early ancestors of human beings that originated from that area. According to the researchers and scientists, the study adds to the evidence that changes in precipitation were fundamental to the evolution and dispersal of hominins in North Africa. A couple of years after this team of researchers released what they considered the origin of the Sahara Desert, a new hypothesis was released. This new hypothesis suggested that about 11,000 years ago, the Sahara Desert would have been utterly unrecognizable to people of the modern age. This is because this arid land used to be alive and covered in green lands pitted with lakes, rivers, grasslands, and even forests. So the next question that comes to your mind is, where did all of it go? To that, a hypothesis was provided by archaeologist David Wright. He said, maybe humans and their goats tipped the balance, kick-starting this dramatic ecological transformation. He suggested that the early humans were the reason behind the loss of the green lands in the Sahara. In a study in the journal Frontiers in Earth Science, Wright argued that the early humans could be the answer to a question that has plagued paleoecologists and archaeologists for years. Regardless, the Sahara has been subjected to periodic bouts of humidity and aridity for a long time. As I've stated previously, the tilting of the Earth resulted in more solar energy for the Northern Hemisphere and more precipitation for North Africa. There's been more energy pouring in from the sun at repeated intervals throughout Earth's history during the West African monsoon season. During those times, known as African humid periods, much more rain comes down over North Africa. The region gets more green lands, rivers, and lakes with more rain. This is what scientists would refer to as stale news, as it has been known for decades. However, what happened between 8,000 and 4,500 years ago was considered strange. There was a rapid transition from humid to dry in some areas. This happening could not be explained by the orbital precession alone, and it ended up resulting in the Sahara Desert as it is known today. Wright said, scientists usually call it poor parameterization of the data, which is to say that we have no idea what we're missing here, but something's wrong. As Wright looked through the archaeological and environmental data, he noticed what seemed like a pattern. Wherever the archaeological record showed the presence of pastoralists, there was a corresponding change in the types and variety of plants. It was as if every time humans and their goats and cattle came across the grasslands, it never remained the same, as they had turned everything to scrub and desert in their wake. Wright thought that this was precisely what happened to the Sahara region. He said, by overgrazing the grasses, they were reducing the amount of atmospheric moisture, plants give off moisture which produces clouds, and enhancing albedo. He suggested that this may have triggered the end of the humid period more abruptly than can be explained by the orbital changes. These nomadic humans also may have used fire as a land management tool, which would have worsened the desert's degree. Other scientists believed otherwise. Geologist Jessica Tierney said, "It's important to note that the Green Sahara always would have turned back into a desert even without humans doing anything. That's just how Earth's orbit works." According to Tierney, humans weren't necessary to explain the unexpected transition of the lush green lands of the Sahara to the desert that it is today. Tierney believed that the culprits might be regular old vegetation feedbacks and changes in the amount of dust. She explained, "At first you have this slow change in the Earth's orbit. As that's happening, the West African monsoon is going to get a little bit weaker. Slowly you'll degrade the landscape, switching from desert to vegetation, and then at some point you pass the tipping point where change accelerates. With the advancement of science and technology, scientists have come up with a way to return the Sahara region to its glory days of ages past. However, this amazing transition seems dependent on climate change, mainly its aversion. This raises new questions. How do scientists plan to do this by averting climate change? We'll find out in due time. Scientists themselves have asked a question: what if the Sahara Desert was turned into a giant solar and wind farm, for instance? This is the topic of new research published in Science by Yan Li and his colleagues. They discovered that all those hypothetical wind turbines and solar panels would make their immediate surroundings both warmer and rainier and turn parts of the Sahara green for the first time in many thousands of years. The scientists behind the research looked at the maximum amount of solar and wind energy that could be generated in the Sahara Desert and the transition region to its south, the Sahel. The two regions were picked as their relatively reasonable sites for such an enormous rollout of renewable energy. This is because they are relatively near to substantial demand from Europe and the Middle East, while having limited other demands on the land. Both have significant potential resources of wind and solar energy. Lee and his colleagues also suggest that the Sahel in particular could also benefit from economic development and more energy for desalination, providing water for cities and agriculture. With the overall sizes of these two areas, it was noted that the solar and wind farms simulated in this study are the sizes of entire countries, which is 38 times larger than the UK. They would be vastly bigger than any existing solar and wind farms and could provide up to 4 times as much energy currently consumed globally. This would prompt significant changes in the local environment. Massive wind farms would raise temperatures by around 2 degrees Celsius, for instance, similar to the amount of global warming we are concerned about. Solar wind would cause a smaller temperature change, around 1 degree Celsius. Precipitation increases of 0.25 millimeters per day associated with wind farms sound more modest, yet this would be almost double the previous amount of rainfall. Again, the effect associated with solar parks was smaller, an increase of 0.13 millimeters per day, but still significant when added up over a year. More rainfall also means more vegetation. This increases surface roughness as with wind turbines and causes more solar radiation to be absorbed as with solar panels. This reinforcing cycle is known as climate feedback, and incorporating this vegetation feedback is a novel aspect of the research by Lee and colleagues. Overall, this is an interesting and important piece of research, highlighting the need to be mindful of the energy transition's unintended consequences, be these positive or negative. Integrating these findings with other social, economic, environmental, and technical considerations is essential to ensure we don't leap from the frying pan into the fire. Let's hear your thoughts about this in the comments section below.